Hello, in this video we are going to demo the app observability end-to-end solution of Grafana Cloud. I'm just going to show you a simple overview of what the setup is going to look like because I'll show you how to install this. But for the demo we'll be using the Grafana Cloud that I have, as well as we'll also use the partner demo website because the data is already there. Okay, let's begin with the overview. We'll be deploying this famous Otel demo application using a Helm chart on our Kubernetes cluster, and we'll change a bit of configuration on it so that all the metrics, logs and traces would be sent to Alloy, which is also on the Kubernetes cluster. Now on the local Alloy, which is on the local Kubernetes cluster, we would be setting up some configuration so that all of this data actually gets sent to Alloy, which is on Grafana Cloud. So from Alloy, Grafana Cloud will take care of sending the metrics, logs and traces to its respective endpoints, memory, loci and tempo. Now all of the data will be available on these three different data sources, which are also added by default on the Grafana Cloud that we see for visualization. So this gives us a chance to actually build any dashboards that we want. But the feature what we're going to see here today is dashboards that come built in even without we creating them. So that's what they call as the app observability solution in Grafana Cloud. So this app observability can be done in various ways, but the way that we are choosing for this exercise is the Otel way. Okay, so that's how the overview is going to look like. We can now go to the Grafana Cloud URL. So this is my Grafana Cloud URL. I'm going to click on the link that says application, which refers to the end-to-end app observability solution offered by Grafana. I already have a few services here because I already tried this exercise some time back. But then I'll just show you how things work. So we'll have to just click on connect data here. And from this page, we can choose OpenTelemetry, OTLP, which is OpenTelemetry protocol. Click on that. We can generate a token here. By default, it will have the set alloy data write option, and that will have sub permissions, which is metrics write, logs write, traces, profiles, and fleet management rate. So all of this will be included with this one single scope. We can create a token, we can give it a name. I've already done this. All you have to do is just put a name here and then you create the token and an API token gets generated for you. All you have to do is just copy the token. Once the token is copied, just come down and just copy this complete Alloy configuration. Okay, and in this Alloy configuration, all you have to do is replace a couple of things at the bottom. So you'll have the username and the password, right? So the username and the password is something that you need to fill. Username is already anywhere there because this is nothing but your instance ID. The password is nothing but the API token that you would be generating at the top. Okay, so let's see the config of Alloy. So this is same what we saw before, right? So only the token is changed, everything else is same. So this is the Alloy configuration that I already have ready in my system, and I've given it the name config.alloy. Okay, now we can go ahead and create the config map with this config.alloy. I'm going to create this with this name and then on this namespace, and I'm using this slightly different syntax. It's because I already have the config map, so it can just get updated if at all there is any change in the config. So I'm just using the dry run and then I'm going to apply this. I think there is a small mistake in the namespace. Let me just go ahead and change the namespace. The namespace that I have already created is app only observability. App only demo. It's not observability. So Oli and then demo is what I've created. Okay, so the config map is now done. After the config map, we just need to look at the Alloy values. So this is the Helm values, and we have got this content. So we're not going to create a built-in config map, so we'll be using an external config map that we defined, and the name of it is Alloy config, which we just created. And after that, we are going to just expose the gRPC 431c port on this Alloy service. Okay, the value is also ready. We can now look at the Helm file. I'm using Helm file to deploy. It's because we can put the configuration in the same file and it will be a bit easy to maintain. So the Helm file for Alloy is in this file, alloy.yaml. So this is the Helm repository that I'm going to call for this particular chart, and then the name of the release and the namespace and the Helm values is all defined here. There's a small change that I need to do in the Helm values, so let me go into this, and I just need to remove the directory because earlier I had it in a different place. So I'll just remove this path, and I think this should be fine now. So the Helm file is ready for us. All we have to do is just put Helm file sync. Yeah, there is no Helm file in my system, I mean on this directory, so I'll have to just call the file explicitly, and the name of the file is going to be alloy.yaml. Okay, I think the Helm release is now getting updated because it's already there. Yeah, if at all there's a change, it gets updated, otherwise it'll just leave it as is. Okay, Alloy is also installed. What else is there? We have to now deploy the Otel demo app. Okay, so let me quickly go back to the diagram once. So on this diagram, we're now done with this part wherein Alloy on K8s is installed with the configuration that is required to send the data to Alloy on cloud. So this part is kind of completed. Now we need to go to the first part wherein we'll be deploying the Otel demo app, and then we'll be passing all of this to the local Alloy. So let's get back to the terminal. The Otel demo app is also going to be installed with Helm. So I've got a Helm values file for that. Let's look at it. So I'm going to disable all of this like Jaeger, Prometheus, Grafana, OpenSearch, because we're not going to use a local Grafana. We'll be using the cloud-based Grafana, so we don't need Grafana as well. The OpenTelemetry collector is what people normally use to actually send the metrics or logs or traces down to the backend, right? So in this case, we're not going to use it. Instead of the OpenTelemetry collector, we would be using Alloy, which is a Grafana product. Okay, just like we have the Helm values, we'll also be having a Helm file for this. So that Helm file is in this one, oteldemo.yaml, and this is the Helm repository we'll be using, and we'll be calling the Helm values. So I'll also have to modify this a bit. So let me get into this one, and I just need to remove the path from the values. Okay, saved. So we can install Otel demo just like we installed Alloy. So Helm file sync and call the file name. Okay, so OpenTelemetry application is also deployed. I already have it, so it is just getting synced if there is any change in the configuration. Okay, so we now have the Otel demo application. We are sending everything back to Alloy on the Kubernetes cluster locally, and then from Alloy, everything is getting sent to the Grafana Alloy on cloud. Let's look at the list of pods on the cluster on this particular namespace. I think everything seems to be running, so it's all good. So we have got around 4 instances of Alloy alone. Just a quick thing on the values file that we have used it for Otel demo. So Otel demo, I think I forgot to mention one thing. So the Otel demo values file. So in this, we already covered, why we have disabled all this is because we don't need this for this particular demo. These are different tools like Jaeger for traces and Prometheus for metrics, OpenSearch, just in case we want to send some logs, etc. Now, there's also one other thing that we have added here, which is the environment override, the Otel collector name, which is equal to Alloy. This is because we're not using OpenTelemetry collector in this case. We have disabled it, and we are using Alloy instead of that, right? And this Alloy is nothing but the name of the Alloy service on this particular namespace. So kubectl get svc -n app Alloy demo would tell you the name of the different services on this particular namespace, right? So Alloy is the name of the service that we are going to use for Alloy. So if there's a different name, we'll have to use that particular name here. So this is just for information. Okay, everything seems to be good. I think we can head over to the Grafana Cloud. Okay, so we already saw how to get the configuration from here, right? And just in case we want to test also, we can do it from the same page. So if the installation was good, we should be able to get data for all of our services on the Grafana Cloud, and we should be able to visualize the built-in dashboards provided by the app observability solution. So here too much data is not flowing due to certain restrictions on the free account. So what I'll better do is now I'll switch on to the partner demo website and I'll continue the demo from there. So this is the partners demo Grafana Cloud instance where they've already configured the Otel demo and all of the data is actually flowing into the Grafana Cloud's visualization. I'm already at the application section, which is the end-to-end app observability solution, and under which we have the services section, and all of our services that belong to the Otel demo are listed. Not just that, I think they also have a lot of other services if I'm not wrong. But anyway, we'll be focusing on the particular Otel demo app. So we'll try to pick something that we know from the Otel demo app. So the accounting service, checkout service. I think we can pick one of this. But before picking, let's see at this front-facing dashboard. So this is like a tabular format wherein they have said what is the name of this particular app and what is the namespace of this and what is the latency. So it's less than 1 millisecond, and this is the 90th percentile latency. So that is what they are displaying by default. But if we get into a particular service, we should be able to see other percentiles like 99 also, an average latency as well. Now other than that, we also have the error percentage, which is like 0%, and then we have rate, the throughput, so 0 requests per second. So these things vary a bit, like 0, 0.3, etc. So this is basically the red method. So RED. So R is like, we can also call it as throughput, and D we can also call it as latency, right? So overall, the performance of a web application can be measured with these vital metrics. Alright, so now let's scroll down and see if there is any one application or microservice wherein we are able to see certain errors, right? So that will be of more importance. So there is one application here which has got 5.3, and there is one other 7.9, and then here we have 42.9 and so on, right? So let's try to pick something there, right? So maybe we'll go with the first one, front end, which is 5.3%. So I'm going to click on this. So this takes me to the dashboard that is meant for that particular service, which is the front end service inside the namespace DITL demo pro. If you see, it says node, so which means that node.js is the runtime for this particular application. And I think this is the Kubernetes symbol, right? Yeah, if you click on it, you see it is Kubernetes monitoring, where is the cluster, what deployment it's using, namespace, and all of these details that are relevant to Kubernetes. We'll come back to Kubernetes in some time, but before that, we'll walk through some of the application metrics or the panels, and then we'll see also the Kubernetes monitoring at the end of the demo. So this service dashboard is also again talking about the same red metrics, right? So you have rate and errors and duration. So the same thing, but we're getting even more details. Like for instance, you have the duration distribution. So this is going to tell you, this is like a histogram. So it is telling you how many requests are of latency 5 milliseconds. So you see here, almost 1000 requests are having latency is equal to 5 millisecond. And likewise, how many requests are having 25 millisecond latency? Just hover and you get the number, right? 953. So this is the idea. And you also have like few other panels, right? So one is the downstream services and databases, which is like from this service, where's the traffic going downwards? So there are a lot of microservices: add, cart, checkout, currency, and product, right? So all of them are microservices, and their respective red metrics are also displayed. And coming on the left side, this is the operation from this particular service. So this service should have handled certain get requests and post requests, right? So what are those, and what is the red metrics again for that? So there are like 7.41% errors in the get request, and post seems to be good, right? So either we can dig deeper per operation, or we can also dig deeper per the downstream service. Now the upstream is on the left side, right? So the front end proxy sits in front of this, and on that upstream connection there are about 7.5% errors. We can actually see all of this information in a different view also. So if you go to the service map here, it would actually tell you, it will actually give you a graphical view of the same thing that you saw. Let me just minimize this a bit, and if you see this, most of them are green, right? So this is green, this is, everything is green. So there are only a few reds here which we need to focus on. So one red is on this particular server, which is the product catalog service, and there is another red here, a recommendation service. And this service, which is at the center, right, is our service, the front end service, the particular service for which we are looking at the dashboard right now. So this service is at the center. So whatever is on the left of it with a right facing arrow, right? So this is the upstream service, and rest of them are all downstream services or even databases at times. So there is no database at this connection because we are dealing with the front end. So only the backends would normally talk to the database, right? Okay, fine. And we also have like few other details, right? So we also have the latency as well as the throughput or the rate, correct? So if you look at any one of the circles, so let's see this one, the product catalog service. At the top, you have 27.40 milliseconds per request. So this is your latency. And after that, you have the reverse of it, right? Which is 0.17 seconds requests per second. And this is your throughput or rate. So whatever we saw on the table, everything is visible on the graphical view also. So let's say that we want to go deeper and find out, about this particular service where we have a red, right? Or this one, anyone can be picked. So let's go with this for now. So I'm going to click on this, and we will be having links here itself. So the service overview will take to the service dashboard of that particular service. So in this case, the recommendation service, I'm going to click on that. So I'm at the recommendation services overall dashboard, right? And all the patterns are already similar, we saw already, correct? So there is a backend service, there is a downstream service on which there are errors, right? So this downstream service seems to be fine. And the front end, obviously we know that there was an error, and that is why there is an error still. And there is one operation that happens from this particular service within this, and that seems to be okay. So now we can actually go to this one, right? So either we can click on this particular link from the table, or we can go back to the service map and we can also click from there. So on the service map, so this is the center one is our service, and on the right we have the downstream services. The top one is good, it's all green. The bottom one we have few red ones, right? So we can maybe click from here, or for this time what I'll do is I'll just go back to the overview and I'll click from there. So I'll click here. Okay, one other dashboard, a familiar dashboard. So the view is all same for all the services, right? So we know what it is. All right. So now if you see, the backend downstream services are not having any errors, but maybe the operation has an error, and that is why it was showing earlier, correct? So this time what we can do is we can actually click on the operation instead of the backend service. So the error can either be there or here, right? So the error lies within this service, within its own operation, right? So we can click on this. Now, what's next? We know that there is some sort of an error in this operation, and that is why we came so far, right? So we could actually go to the traces section. And now this section is going to give everything for this particular operation. So even if there was a successful operation of this type, it will still be shown, but we are actually interested in only the error, right? So for that, what we can do is we can just change the status to error in this filter, so that we are only looking at the error operations. Okay, now we got a lot of traces, right? In each of these traces, the idea is in each of these traces, there would be at least one operation that is of type list products, like product catalog service list products, and there could be other spans also. But the idea is this particular operation will be definitely there in one of the spans. So trace is nothing but a collection of spans. So one trace can have multiple spans, and one span will have a particular operation type. And in this case, any one of the spans in each of the traces will have at least one operation that has product catalog service slash list products. Okay, so we can now maybe explore one of the traces to understand more about it. So I'm going to click on this, and I get a view of this particular trace on the right side. One trace can have multiple spans. So the span that you're interested is this one, right? Because this is what we are filtering. So we are filtering for this span ID. I mean, the ID can be anything, but the operation is this Otel demo product catalog service slash list products. So we can click on this one. So even if I click on this one, it is going to open the complete trace for me. And in this particular trace, it's a big trace. One of the operations is this, which is the final operation, because we traveled from a different microservice, and when we came all the way till this, right? And there were no downstream service errors, and that is why there is no red after this. This is the final red, correct? So this and this are not having any red on them, because we saw that the services were okay, only the operation was having a problem. So we can better click on this. And if you click on this, you get more details about this particular span or operation. And there is this beautiful correlation, right? So you have correlation from traces to logs and traces to profiles, and then you even have traces to metrics. The traces to metrics correlation is what helped us with a lot of dashboards, right? So we were able to see the red metrics and everything just because the traces were getting converted into metrics as well. And we also saw that in the diagram that we have a traces metrics, and that was going down to mirror. Okay, now we have a logs correlation and then profiles also. And if you want to click on this events to get some more information even before we click on the logs, right? So we'd be seeing some errors here. So there are some errors like PQ, sorry, too many clients already, and so on, right? This is something a developer would definitely understand, because it's their application, and by looking at this error, they would have coded this, right? So they know what this error is actually coming from, what PQ means, right? So these things they would definitely know. I think there are too many clients, and that is why the connection is not getting succeeded. And we also see a 500 here, right? So the overall status code is 500, which is a server error. we already got the information, but if we still want, we could also click on this logs for this particular span, right? And maybe we'll be able to see the same information there also. Click on this. So we are still on the service dashboard. We didn't move anywhere else. We are just on a different tab. So earlier we were on the traces tab, and from one of the links on the traces tab, by clicking on the logs for that particular span, we came to the same dashboard. We didn't move anywhere else, but we are on the log section with a predefined query based on what we clicked. Okay. So this is also going to give some more information for us, right? But there will be a lot of logs, right? So we are only interested in the red ones, right? So maybe we can click on any one red. So it is going to tell that there is a runtime error, invalid memory address, or null point, and then maybe we can click on one other red. And here also you see, right, from the top level itself, there is a level is equal to error, and that tells you that PQ, sorry, too many clients, right? And this is kind of matching with what we saw during the traces section. So this is how actually we can do a lot of debugging, and then from within Grafana, even without getting into the kubectl tool or maybe any other tool, right? So we can get everything from the dashboard. A lot of correlation is there, and the overall MTTR is greatly reduced. So far we saw two things, right? So one, we saw the traces to metrics correlation and some of the dashboards that were made using that correlation, right? For example, this duration, if you explore, this is nothing but a PromQL query, right? These are nothing but metrics that are actually generated from the traces. So we are sending the traces, and those traces are actually getting converted into some other metrics. So that's what we call as trace to metric correlation. And these metrics are actually stored in Prometheus. And if you see this, there's a Prometheus icon, right? So that's nothing but the member, which is a Prometheus type data source. Let's go back one step. And then we saw the traces to logs correlation, wherein we were able to click on one of these, and then we went to the traces, and from the traces we saw a particular span where there was an error, and then we clicked on the log for that span, and we went into the logs. So this is kind of a correlation from traces to logs, right? And these logs are stored in Loki. So which again is a predefined like a built-in data source in Grafana Cloud. So we didn't have to add any of this. So we didn't add tempo, we didn't add Loki, right? All of that was existing. And even member. And one other thing we also saw about the service map, how we can actually interpret the graph, and even without seeing these dashboards, we can also interpret the service map directly, and we could also travel to different places from within the graph, right? So we saw that too. And there's one more thing. The application will also have certain metrics instrumented directly with OpenTelemetry, right? For instance, it could be Prometheus or OpenTelemetry, but in this case, we are actually dealing with Otel native metrics. So this is a Go application. By looking at it, it says that it is Go and it is running on top of Kubernetes, right? Now, if you go to Go, it's nothing but the direct metrics. It is not a trace to metric correlation, or it is nothing to do with logs, right? Those are direct metrics coming from the application, instrumented specifically for the metric side. Since this is a Go application, the Grafana Cloud team has a logic to actually pick only the Go metrics, even though the application may have a lot of other metrics, like maybe it has HTTP, maybe it has process and so on, right? But they're only picking the Go application metrics because it's based on the Go runtime, right? So you click on this and you will be able to see some very key metrics that are related to Go. Likewise, if you go to some other dashboard, right, some other service, for instance, maybe you want to go with ad service, it's I think Java, and this is .NET, and this is C, a lot of other things are there, right? So let's pick one. Maybe we'll go to ad service and see the Java metrics. The JVM metrics will all come here. So all the important key JVM metrics are going to be displayed even without you have to do any configuration, and all of this is in time series. It's all trend, right? So we get a lot of things built in even without we have to configure anything, right? So that's I think a very cool feature. And one last thing, so here you see that Kubernetes is also there, and AWS related metrics are also there, right? Because it's saying that on AWS it's running on what, right? Maybe it's running on EC2 instance, which might be one of the worker nodes, correct? So some information related to that is also there. And if you click on Kubernetes, you also have certain hyperlinks, right? So you have hyperlink for Kubernetes monitoring, and then you have a hyperlink for each of these things, right? Because the Kubernetes monitoring is also set for this application. Now, just like we saw the app observability, a Kubernetes monitoring is a different end-to-end solution that is also provided by Grafana Cloud. So if you click on this one, you would be seeing another hyperlink, for infrastructure, and under that you have like Kubernetes, and you also have AWS, right? That is why you're able to see a lot of links for the Kubernetes. So maybe we'll try one link from here, right? Maybe what we'll do is like since we're dealing with an application better, we'll click on the pod name that refers to this particular application, right? So this is the complete pod name of this application. So let's click on this and see what all we get out of those built-in dashboards. I think there is some useful information like the number of restarts for the pod, and then the status of the pod, when did the pod start, which cluster the pod belongs to, and I think there's also a hyperlink that will take us to the cluster dashboard, right, and also to the node or the namespace level dashboard. And we have the general, the normal, like the CPU and memory utilization of this particular pod. We see the number of cores and MIPS used by this, the maybe bytes, and the limits and everything. Yeah, some useful information that I can find here is the cost as well, right? Let's click once on cost. Okay, so this is very good information in terms of what we can actually save and what's a prior 30-day period, right? So the total compute cost for the last 30 days and how much it got reduced in terms of percentage, right? Yeah, overall we got a lot of dashboards built in. So with this, I think the demo is coming to the end. We saw more on the app observability side, and we also touch based a few things on the Kubernetes monitoring, and both are like built-in dashboard visualization solutions provided by Grafana Cloud. And all we have to do is like a bit of instrumentation from our side for the apps, and maybe a bit of installation for the Kubernetes monitoring also, though we have not seen much on how we can actually install the Kubernetes monitoring. Okay, so that's it for this video, and thank you so much.